I just realized I forgot to talk about comments last time when I was going through the basic Python syntax. So a comment just means some stuff that you want to write down for the human reader of the code that the computer ignores. And in Python, you can put the comment on the end of a line with this hash symbol. So everything after that on that line is just going to be ignored. And the other thing you can do in Python, we talked last time about how if you use triple quotes, you can have a string that is multi-line. So the way you make multi-line comments in Python is you actually just make it a string. And the string does get evaluated by Python, but then you just don't do anything with it. So it ends up not affecting your code, and it's just kind of a weird way of having multi-line comments. So, I mean, just like I can have a line of code that says 7, and you're not doing anything with it, so that line of code does nothing. In the exact same way, those lines of code with the string define the string, and then they don't do anything with it, so that also does nothing. And you can just put comments like that. Whereas this line of code actually does something, because you set x equals 1. OK, another thing I just want to quickly talk about. So I understand Rodolfo talked a little bit in the first platform lectures about why we chose the various tools, and he talked about how Python is super popular. I just wanted to say one other thing about that, which is it's good if a language is popular because you apply for a job and there's a good chance they use Python there and you know Python, and that's great. But there's another reason why it's good that the language is popular, which is that a lot of times when you're programming, the fact that other people are programming in your language makes you more effective at programming. Because, for example, you have a question, you go to Stack Overflow. 1 million people have already asked that question, and so you can get an answer really easily. Or no one's asked that question, you ask it, but so many people use Python, someone answers it really quickly. And probably most importantly, something we're going to talk about next week is packages and libraries, meaning pieces of code that other people have written that you can use. The more people using Python, the more of those there are. And we're going to use a ton of different packages in MDS. So that's just another reason why it's good to use a popular language beyond the fact that it's likely someone might ask you to use it. OK, next thing, loops. So loops. You've likely seen loops before in some other programming language. Loops allow you to execute a line of code more than once with something slightly different each time. So the syntax in Python is for, then the name of a new variable that you're defining, in, and then this could be a list or a tuple or a bunch of other things that we'll talk about later, but something that has a bunch of stuff in it that you're going to be iterating through, in this case a list with 4 elements, and then the loop to signal that you're inside the loop. So it's just like the if statements that we talked about on Tuesday. The indentation controls whether you're inside the loop or outside the loop. And every time that line of code executes, the value of n changes. So as you can see by what's printed out, the first time n is 2, the second time n is 7, and so on and so forth. So this loop is going to execute 4 times because there are 4 things in this list, and n is going to take each of those values once. So to summarize, 4 keyword, colon, we can iterate through a bunch of different things. Indentation and the variable n takes a different value each time. So here's just, let me do this. Okay. So here is just a fun little example again. The thing that you're iterating through here is a string. So you don't even have to do, well, that's fine. So as we talked about last time, strings behave sort of like lists. So you get the first letter, capital P, the second letter Y, et cetera, et cetera. Any questions about loops? Yeah, what's your name?
Reiko. Reiko.
Reiko.
Yeah, in your first print statement, you use commas. But in the second print statement, you use plus signs.
Good point.
Can you just elaborate on that?
Yes, so the question was, in my first print up here, I used commas, and the second one I used plus signs. Okay, so the plus sign one, we talked last time about how the plus sign can mean different things and for different data types. So like when you add two integers, it adds them like mathematically, but when we added two lists, it concatenates them. So the plus sign for strings behaves like it does for lists, that it just jams them together and makes one big string. That's called concatenation. So what's happening here is that I'm just creating a new string, which is give me a plus the letter plus exclamation mark. So that's first turning into a new string, which is the whole thing I want to print. And then all that is getting passed into print. What's happening above with the commas is something that is special to the print function. So the print function allows you to just keep adding more and more things with commas, and it will just print them all and put spaces in between them for convenience. So the one at the top is a special print thing. The one at the bottom is a general combining strings thing. And then, of course, the other way of doing it were the things we talked about last time with the string formatting, with the percents and the format, and there was now 3 ways of doing that. So there's about at least 5 different ways now of accomplishing this, and from my perspective, it doesn't matter that much which one you use. Any other questions? Name? Say it again? Brandon.
I don't know if we're going to get to this as we do the entire thing yet, but so this is for if we're iterating through a fixed set of things. What is the most effective way to just do an action at a fixed number of times? Let's say we want to do something like that.
The question is, what is the most effective way to do an action some set number of times? So that is coming up. So here it is, in fact. So range is a special function in Python that when I say range of 10, it is going to give me something I can iterate through that goes to integers 0 through 9. And so to do what Brandon wanted to do, I just want to, maybe I just want to print, hello 10 times. I don't even want to do something different every time. Then this is going to print hello 10 times. And if you want to see what the variable I is, it is those integers from 0 through 9. So range is quite commonly used in conjunction with for loops in Python. Okay, range also has some fancier aspects to it. So you can specify a starting value if you don't want it to be 0. In this case, I'm starting from 1. You can also specify a skip value, in this case 10. So now it says start from 1 instead of 0, go until 101, but skip by 10 every time. So there's some fancy little options there. And here is a nested loop. So we talked about nested if statements last time. You have an if statement within an if statement. You can also have loops within loops and all combinations that you can think of. So here, x is going to be 1, and then y is going to be 1, and then it's going to print them. And then y is going to be 2, and then y is going to be 3. And then we're reaching the end of the inside loop, and so now x is going to be 2. And this is what we get out. Yes? Sukriti? Yeah.
In this example, so we're getting one with first with 1, then 1 with 2, 1 with 3, and so on. Then we're getting 9 different values.
Yeah.
Is there any possibility that I can get 1 with 1, 2 with 2, and 3 with 3? The first element with the first element.
Sort of. Yeah. Okay. So the question was, well, let me actually change this to make the question. So I think, yeah, what you're asking is I want to get 1 in A, and then 2 in B, and then 3 in C, right? Yeah, so if I was doing that, I would do something like this. So I would make an integer index for my loop, and then I can just grab the corresponding element from each list. Any other questions? Okay, so this type of thing, nested loop, not the most obvious thing the first time you see it. I'm imagining most of you have seen nested loops before. If you haven't, I would recommend doing some extra practice or coming to talk to me, because this part is not the kind of thing that you can just look at for the first time in 10 seconds and be like, oh, of course, this is what it prints out. But the rough idea is that for each of these values of x, it is doing the entire loop for y. So when x is 1, you get ABC. When x is 2, you get ABC, etc. Okay, we talked about dictionaries last time, so you can also loop through dictionaries. Here's a dictionary mapping course numbers to descriptions. And the ways you iterate through dictionaries is that after the for, you actually have two variable names. So instead of just for n, we have for course number, comma, description in courses, that's the name of the dictionary, dot items. So dot items turns the dictionary into a thing that is convenient to loop through. And then I get this. So, right, here's the general pattern below. For key, comma, value in dictionary name dot items. That's a very common thing to use. Okay, in addition to for loops, there's also while loops. Again, you may have seen while loops in other programming languages. I don't use them very much, although occasionally I do. So a while loop, a for loop just goes through each element in a collection of things. A while loop actually just goes forever as long as the condition there is true. So I'm setting n to 10, n greater than 0 is currently true because n is 10, so we're going to go through it. But I'm making n smaller every time, and eventually n is 0, and 0 is not greater than 0, so it doesn't do the loop anymore. And as it says above there, if you didn't have this and you ran it, it's just going to loop forever, and then you need to press the stop button up here, or just Control-C out on your terminal, because otherwise it's just going to keep going. Okay, that is it for loops.
On the previous one,
Your name again?
Robert.
Robert?
On the previous one, is the courses there's no?
Previous one. Yep. Mm-hmm.
So that's going to bring out the key.
Yeah, so let me go up a bit more. So here, let's say all the way back up to here. So this n, I could have picked it to be anything. It's just a name of the variable, and it's just for being used temporarily inside the loop. So I could have called that n. I could have called that Robert. As long as I call it Robert here and everywhere else, it's all good, right? So likewise down here with the dictionary, I could have called this anything. I could have called it K as long as I put it K here. But the point is, the first thing is going to be the key, and the second thing is going to be the value as you iterate through the dictionary. So since I already knew that this particular dictionary maps from course numbers to descriptions, it just seemed reasonable to name that thing course number because I knew that's what was going to get stored in there. Yeah. Your name again?
Gaurav.
Gaurav.
Yeah. What does that dot items do? Does it pull in each pair every time?
Yeah. What does dot items do? It basically just gives you something that can be iterated through that contains those pairs.
So every time I use that, it will go to the next item. Is it like that?
Not really.
Typing it 2 times or something like that.
We'll talk more about that a bit later, but you can, just like range gives you something that you can iterate through, you can think of items as gives you something you can iterate through. Yeah, what's your name?
Zachariah.
Zachariah. Yeah.
does the recursive dynamics function always require to have two variables to be declared, or it can be more?
Yeah, there's always going to be two variables because dictionaries are always mapping a key to a value. That's what a dictionary is. So you're always going to have two things pulling from the dot items.
So if you want only the keys.
Okay, right. Okay, that's fair. Fair point. So, in fact, if you don't do dot items, it gives you the keys. And once you have the keys, you can certainly get the values by just indexing into the dictionary the way you would always index into the dictionary. So the items thing is purely a matter of convenience. It's not actually needed. You could always just do this syntax where you don't use dot items. It only gives you the keys, and then if you need the value, you go back to the dictionary, index it with that key, and get the value. Did that answer the question?
Yeah, it's a simple.
Yeah? Okay. Yeah, so, right. Any other questions? Yeah, your name?
Arun.
Arun?
Arun.
Arun. Yeah, got it.
Is there anything like do while in Python?
Is there a do while in Python? I don't even remember. You don't really need them. I mean, you can check. Yeah, but they're basically the same as whiles, just like slightly more convenient in some cases. Yeah. Okay. Here we go. Comprehensions. So comprehensions, again, they're just convenience things. They do not do anything that you couldn't do otherwise. They just are nice. So let's say I have this list of words. Here's this weird line of code that you haven't seen before, probably, where I have these square brackets. So it's like I'm making a list, but instead of making a list and saying, here's the stuff I want to put in the list, you actually stick a for loop right inside that definition of the list. So what this says is y is going to be a list, and to build that list, I'm going to iterate through words using the variable word. And each time I'm going to get word -1, meaning the last letter of the word. And so that's going to build me a list that has the last letter of each of those 4 words. I could have just the same. Do I have this below? No. Okay, so equivalent thing would be this. This is, it's just kind of, nice to just have it all in one line like that. It's purely a convenience thing. Yes, your name?
Annie.
Annie?
So when you press or take it into one line, is it always, before you had for this and this, do that? And then when you put it together, it's always do that for this and this?
Yes, that's right. You do flip the order. You have the thing you're going to do before the loop syntax. That's correct. But furthermore, it's not quite do that. It's like do that, and then whatever comes out, that's going to be an element of this list we're building. Whereas with the regular for loop, you're not necessarily building a list at all. You're just doing anything. Here, you're necessarily going to be left with something, and that's going to get stored as the next element in the list. So you can have, these are called comprehensions. You can have them for tuples. You can have them for tuples, but this is not how you do them. Let's talk about that in a second. So you can have them for sets. This now makes a set. As we talked about last time, sets just have unique elements. So here, E got added into the set twice, but with sets, you can't have more than one thing, so we don't have that. You can have a dictionary comprehension. So here, I use the curly braces for a set, and I'm using the curly braces for a dictionary, but with the colon in here, which is how Python knows it's a dictionary comprehension. And here I'm saying, let's map from the word to the length of the word. And so it gives me this Dictionary comprehensions, yeah, they're super useful. You probably won't be able to remember all these comprehension things right now, but you can refer back to this. Try using them. If you see them, this is what it is. The tuple one is kind of a gotcha, because you would think this was obviously a tuple comprehension, because it's exactly like the list one, but with parentheses instead of square brackets. But it's actually not. It's this weird thing that we're going to talk about in a later course called the generator. So I'm just going to leave that for now as something that is not what you think it is. And we'll talk more about it later. Your name?
Kenneth.
Kenneth.
Is it possible to put conditions before loop?
Yeah, is it possible to put conditions in? So yes, there's even fancier versions of comprehensions where you also have like if length, if something about the word. So you can look that up, but yeah, there's that slightly fancier version that only keeps it if something is true. There's another question? Yes.
Yeah, Furkan.
Furkan.
Yeah, so for comprehensions, like say it can have if-else statements and for loops. So it can have, like say, what is the resource to get, like say, what it can does?
Well, I don't think it goes much beyond that. I think you can have for and you can have if. You can maybe have multiple fors if I remember correctly, but I would not recommend doing that because that's just not going to be readable at some point. Just because you can do something fancy doesn't mean it's necessarily a good idea, because once it becomes not readable, then it's not actually that useful. Okie dokie, functions. Function is a block of code. It's kind of like a mathematical function, like cosine or whatever, but it's a piece of code that you get to define. You give it a name, and you can give it inputs, and it gives you outputs. That's essentially it. So here's an example. Define a function called square, and now I can square all of these numbers. And what it's doing in here is, so def just says I'm defining a function. Square is the name of the function. You can name it whatever you want. And then now you define the inputs that are going in. And just like we talked about before with Robert's question about the variable names, like you could use whatever variable name in a loop as long as you refer to it correctly later. It's the same here. I could call this n or whatever I want. But once I put n up here, I need to refer to it as n inside of the function. And then return tells you what the outputs are going to be. So you could have much more complicated functions. As we'll see, this is just a one-liner. It just takes a number, squares it, returns it back to the caller of the function, the person using the function. Questions about this syntax?
So sometimes I've seen that return on the side and then like ending the definition. Can you provide examples like that? The return part, do you always have to put the command next to the return?
Oh, do you always have to put a command next to a return? Well, it kind of depends how you define a command. There has to be some sort of value. So you could do this. And it would be exactly the same. Either way, it has to be something that gets evaluated to some sort of value, and that value gets returned. And whether you put a giant mess of code there, which I don't really recommend for readability, or just the name of a variable, either way is fine. Annie, was it?
For something as simple as that you have selected, do you need to write a docstring?
We'll get to that. We'll get to that. Okay. Scrolling down here. So side effects. Here's a function called silly sum that for the most part just sums the elements in a list, but it has this silly aspect to it that it appends 0 to the list. Who knows why? And if you call silly sum, it seems like it's working. It adds up all those numbers. 1 plus 2 plus 3 plus 4 is 10. That's great. And if I actually stored this in a variable, then my variable actually got changed. And if you're supposed to be a function, and we talked about a bit last class, but if you're supposed to be a function just adding a bunch of numbers together, please don't mess with my data by adding a 0 for no reason, especially if you don't tell me you're going to do that, right? So that's called a side effect. So this function is doing something and changing the variables at the same time. And yeah, basically, it's okay to do this sometimes, but you need to be very clear in your documentation, which we'll talk about later today, that you're doing this. And it's just a little dangerous. Yeah, what's your name again?
Sri.
Sri.
I was wondering, like, if we use another variable name as the argument instead of LST, will the same thing happen?
Absolutely. This variable name doesn't matter. So, what was your name again? Sri?
Sri.
How do you spell it?
SRI.
Okay. So if this is my variable name, all the behavior is exactly the same. I would recommend thinking about it as, it's not quite true, unfortunately, but I would recommend thinking about it as this variable name just kind of exists inside the function.
No, I was wondering about, like, will it append the 0 to the list, actual list?
To the actual list?
Now I have the list name as LST.
Yeah, no, it totally does. I just reran it.
Oh, okay.
Yeah.
Thanks.
Tom? Tom?
Yep.
Yeah.
So let's just say we do have to write a function that does something to your original data. Would it just be a good practice to store the original data in some sort of variable and then return the variable with it, or?
We'll talk a bit more about this next class, but for now, if you're going to do this kind of thing, at least make sure it's very clear in the documentation.
Do we need to change?
Frank? Right? Yeah.
Do we need to change LST to SRI signal language?
Yes. Right. And this is why Python is devastatingly sad sometimes. Yes, this should have been Sri all along. Thank you. I think there's a question over here somewhere. Maybe? No? Okay. Okay, moving on. Last thing about functions is that if you have a function that does not return anything, like if you don't have a return statement, or you have like, you know, you have a return but it's inside of an if and you're not necessarily going to get there. In other words, if you reach the end without returning, it just returns none by default. So I'll just show you that here. Just something to be aware of. Okay, next stop. The don't repeat yourself principle and designing good functions. So consider the task of, for each element of a list, turning it into a palindrome. So I need to turn Mike into Mike Kim for some reason. That is what you want to do. So here's my solution. I take this list of names, and I want to get a new list that has all those names with this operation done to it. So here's what I'm going to do. For each one, oh, by the way, I should just say the following, that we talked about slicing into lists last time. So this is the way you reverse something with slicing into a list. It's basically saying, get me everything, but count from the end backwards. So fine, not the most important thing in the world, but this syntax here just gets me the thing backwards. So I'm going to make names backwards. I'm going to get the first one, make it backwards, and combine it with, so it's going to be Milad and Milad backwards. It's going to be Rodolfo and Rodolfo backwards. And we just talked a few minutes ago how when you use the plus sign for strings, it concatenates them together. So that's all good. So this code actually works. It does the thing we want to do, right? It produced Miladalim, Rodolfo, Flodor, and I'm not even going to try the last one. So it works, right? But just because your code works doesn't mean it is okay. So I'm going to just put it out there that this is gross, terrible, yucky code. And the reason why, or the reasons why, well, first of all, this code only works for lists of 3 elements. So if I wanted to add someone else's name and have a list of 4 elements and do this operation, I'm going to have to add another line of code, which seems kind of ridiculous. It only works for a list called names, because names is embedded in here a ton of times. Here, 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 here. So if I change that variable name, I have to change that at least 6 times, which is a huge hassle. Furthermore, if we want to change something else about it other than the variable name, like, I don't know, make the string even longer or something, I got to change every line of code, even though there's a pattern here. Each of those 3 lines is pretty much doing the same thing. So maybe we don't need to repeat ourselves, right? Don't repeat yourself principle. And finally, it's just like, who's going to look at this and tell you within 10 seconds what this code does? It's a total mess. And this is something we're going to emphasize a lot in MDS, which is if code runs, you're not done. Like, you can't just declare victory because the code runs, because code is like for machines to do stuff with and also for humans to do stuff with. And it was interesting. I started out writing a lot of bad code. Let me just say it that way. So I'm a big fan of working on that. And it happened to me so many times in my life that I came back to my code, a year later, and I just had no clue what was going on. So we want to try to avoid that in MDS. So how can we improve this code? Well, here's the first improvement. As I was kind of hinting earlier, we just have those 3 lines of code that pretty much do the same thing, and we just talked about loops. That's what loops are good for. Let's just put in a loop. So let's make the list same as before, but instead of just literally copy and pasting the code for each element of the list, that's exactly the use case of a loop. For name and names, now we're going to append whatever that name is, fill in the blanks as you're looping through the loop, plus the backwards version of itself. And that works fine. Okay, so progress. And we've solved some of those problems. Now this would work with lists with more elements. We don't have 3 lines of code, but we're not done. We still need to make it a bit better. Any questions or comments first before we proceed? Okay. So here's what I'm going to do now. I'm going to make a function. I'm going to make a function called make palindromes. And it is going to have all of this code pretty much just pasted in it. If you look up here and down there, everything's exactly the same except for the return statement being put on the end, because I need to return the list at the end of the function. And then here I need to call the function, and I'm going to call it with that list of names that we had before. And that works. And what's nice about this that we didn't have before is if we had a list called something else, X or Y or whatever, we could just pass it into make palindromes. We didn't have code that was specific to a particular variable name, and if we wanted to make palindromes on this list over here and that list over here, we wouldn't need to copy and paste that whole loop. We could just use the function. Yeah, so here it is. We have 3 lists of strings, and here's the way I don't want you to do it. So before we had 3 lines of code for each word in the list, and then we had a loop to deal with that problem. But now what if we have 3 lists, right? Then you could do this. Just make a specific code for each list using a loop, and again, it's going to work, but it violates the don't repeat yourself principle. On the other hand, I just have my function, and I don't need all that stuff repeat. And now imagine the function was 20 or 100 lines of code long instead of 2, right? You don't want to be copy and pasting all that stuff for each list. So there's kind of 2 levels of improvement here. Separately copying and pasting the code for each element of the list, not good. Horrible, I would say. And then separately copy and pasting the loop code for each list, pretty bad as well. Although if you're pretty sure you're only going to do this once, then there's maybe no need to make a function out of it. But if you're in this use case with multiple lists, then it seems somewhat reasonable to put it into a function. Questions about this? There's only so much I can convince you by just talking that this is a good idea, but you kind of need to feel the pain personally to understand why it is important to do this. And well, maybe you'll just believe me and that'll never happen, but quite possibly it will, and then maybe you'll think about this class.
Yeah, so.
Oh, yes. Furkan.
So, like, say, do not repeat yourself. Is it true in, like, say, all cases? Because I know in coding, you can run into a situation where things are not possible because they are so coupled with each other.
Yeah, I would say do not repeat yourself. The question was, is it a hard and fast rule? And I would say no, it's more of a guideline. There are going to be times where you're going to repeat yourself, and if I was there looking over your shoulder, I would be fine with it, kind of thing. Especially if maybe you're just doing something twice and you're like, okay, I don't feel like dealing with this, it's not that big of a deal, or whatever, it's just too much hassle. It's fine, but it's more of a, yeah, as I said, a guideline, and more often than not, turns out to be a good idea. But sometimes it takes a lot of upfront effort to not repeat yourself. You have to restructure your code or whatever, and it's often worth it. It's not always worth it, but often is, yeah. Your name?
Rock.
Rock?
Yeah, ROC Rock, yes.
Rock.
Just about that slice from the list, like column,
Yeah.
-1. I searched it up and kind of understand that the -1 is the step, like some
Yes.
step, and in that way you get it like backwards.
Correct.
But I'm wondering why it's not working if I put like 1 column 5 column -1 and I get nothing.
Don't know. Let's worry about that. Let's talk about that after, because I'm already going to run out of time. Yeah, the question was about the slicing and some specifics of it. Yeah, or just throw it in Slack and I'll answer it after class.
Okay, sure.
Yeah. Okay, so here's an even more kind of abstracted thing you could do if you really wanted, is you could make a for loop to loop through the lists, and then each time you're going to call the function for one of those lists, and inside that function is another for loop that is looping through the words, and at the end of the day it's going to get the job done. But now this opens a big can of worms of essentially design. How am I going to design my code? Because now we have a loop inside of a function inside of a loop. But we could have a function inside of a loop inside of a loop, or a loop inside of a loop inside of a function. There's like, it becomes a design question because all of these things are going to get the job done and produce the correct result. But it depends how you're planning to reuse this later and what is kind of a sensible functionality. And it's not like, there's not clear right and wrong answers here. It's kind of a matter of thinking it through, of experience, of who you're working with. All these kinds of factors come into play to make these kinds of decisions. So, yeah, don't repeat yourself, but how far do I take this? And not just how far do I take this, but what is a good unit to be a function? And to contrast, for example, above I have make palindromes, which if you recall, make palindromes with an S at the end, plural, takes in a list, loops over the list, makes them all palindromes and returns the list. But maybe I should just have make palindrome, that is my function, that only operates on one word, and then, as I said, have the two loops on the outside. A loop over elements of the list calling this, and then a loop over lists outside of that. In my personal opinion, in this example, this second case is actually a better design. I would rather have a function called make palindrome that just does the core functionality of the problem we're solving here, and then wrap that thing in a loop if I need to do a bunch of things in the list, and wrap that in a loop if I need to do a bunch of lists. But this is kind of a unit of space in my brain, I guess. It's like a thing we're doing. We're turning a word into a palindrome, and so I like for this to be a function, and it just gets confusing if I make it more complicated. And in fact, I could use a loop, or I could even use a comprehension that we just talked about earlier today. So this comprehension syntax basically replaces what we had called make palindromes before, because it makes a list where all the strings are turned into palindromes. But to me, this is much more readable, because it's like, I'm used to seeing comprehensions. Maybe you're not. Maybe you've seen them for the first time today, but eventually you will be used to seeing them. So I just look at this and I immediately think, okay, I'm doing something for every element in the list. What is that something I'm doing? Oh, it's make palindrome. Got it, done. Whereas the other one is like make palindromes. There's something going on in there. Is it operating on a list or a bunch of lists? It's like, it's a bit much to my tastes, I guess. So yeah, there's a bunch of blurry decisions to make here. Any thoughts about all of this? Your name?
Saurav.
Saul?
Saurav.
Saurav.
Yeah.
Okay.
So in the second case, yours the function runs like 3 times.
Yes.
Function is called. The first case, the function is run 1 time. So would the second case be slower compared to the
yeah, okay. Interesting point. Saurav's question was, in this case, I'm calling a function 3 times. Wouldn't that be slower than in the other situation I'm just calling function 1 time? Okay, a lot to say there. First of all, we won't really be thinking about the speed of the code running until the algorithms course, which is next block. But second of all, in 99% of situations in your life, I think, the speed is not going to be a problem. And there's this quote, like premature optimization is the root of all evil. Maybe you've heard of it, doesn't really matter. But basically, don't waste your time making it faster until you are sure that it's too slow. Because A, you will waste your time, and B, you will probably make the code less readable. It is almost always a trade-off between speed and readability, not always. And third, in this case, I'm not even sure if it would actually be slower. Maybe a little bit, but yeah, not a concern, I would say, for a variety of reasons. Almost always, I would just maximize readability. Because again, there's human time and compute time, right? And the total time is kind of the sum of those two things. And most cases in your life, the human time will be the vast majority and the compute time will be slow. And so I'd rather just save you human time and make it readable so that you can, and more modular and sensible and all that kind of stuff. And worry about compute time only if necessary. Any other questions? Okay, let's take a break and let's resume at 11:48. Here we go, keyword arguments. So sometimes it's useful to have, you can come back to your seats if you were, yeah, that's fine. Sometimes it's useful to have default values for functions. So in Python, these default values are called keyword arguments, and here's an example. I've defined a function called repeat string. It takes in s, and then it also takes, you can go back to your seat, it's fine. It takes in n equals 2, and it returns s multiplied by n. By the way, what does multiplication do for a string and an integer? It repeats the string that many times. So, you know, Mike times 3 is Mike, 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 that kind of thing. So I can call this function, and it works. So it takes a string MDS, multiplies it by the number 2, takes string MDS, multiplies it by the number 5. But here I can call the function without specifying n, because I gave n a default value of 2 when I created the function, when I defined the function. So I have to specify s. I cannot call the function like this. That wouldn't make any sense. But I can skip n, and it just uses the default value of 2. So that's an extremely common and useful syntax. And just some comments about it. You should pick a reasonable default if you're doing this. Like, I think 2 is reasonable because if I just tell you I'm going to repeat a string, repeating it so that it's twice as long, like, kind of seems like what you might think it would do. So that's why I picked 2. As far as the syntax is concerned, you could have any number of regular arguments and any number of keyword arguments, but all the keyword arguments have to come at the end. So you can't have a, comma, b equals 5, comma, c. That's going to throw an error. And here's how it works. So here's a function that takes in 4 arguments, a, b, c, d, and all it does is prints out a, b, c, d. That's it. And I'm going to call that function with 1, 2, 3, 4, and it prints out 1, 2, 3, 4. Makes sense. But I can also call it with just 1, 2. And now a and b are getting mapped based on the order. Because a is before b and 1 is before 2, it's going to set a equals 1 and b equals 2. So for those non-keyword regular arguments, it goes by the order. And now c and d were just the defaults because I specified the string default to be the default. That's getting printed, but I could also do something like this. And you could also do this, which I don't really like that much. Although, I guess if I'm okay with that, then I should be okay with this. Yeah, whatever. It's just a matter of taste, really. So I can specify only C and leave D to be the default. I could specify only D and leave C to be the default. Or I could specify them. This is like somewhat weird, too, because I'm specifying them in the other order. But the order of D and C here doesn't matter. I'm clearly stating D needs to be 4 and C needs to be 3, so that's what's going to happen regardless of the order. So a bit of stuff to just remember and get used to, but it's a super useful feature of the language. Questions? And by the way, I have to write C here because the variable is named here. I can't say, that's not going to work. So I have to use those proper variable names. Okay, I sometimes have some optional stuff in the lectures. I don't cover those in lectures typically, but for those who are interested, you, of course, have access to these notebooks, and you can read through it later if you're interested. Okay, we already did the break because we reshuffled things. So next thing, docstrings. And some of you were asking about docstrings because it appears in the lab, so that makes sense. So we had all those problems with my original code, and the last problem was that the code was not very readable. And it got a little better when I made the function make palindrome, because at least I saw I'm doing something called make palindrome. It gives a bit of structure to the code. But what would be even better is if I wrote in English what the function actually does. So here I have what is called a docstring. That's short for documentation string. Documentation meaning like write down what you did. And it's just some stuff you write down in human language saying what it does. Turns the string into a palindrome by concatenate itself with a reversed version of itself in this case. So there's a lot of cool things about docstrings. One is that in Jupyter/IPython, you can use this question mark, make palindrome question mark, and it'll say what the function does, including the docstring. So this is not that useful for functions that you wrote, because you probably know what they did, but it's super useful for Python functions. Let's try print, maybe? Yeah, I mean, it's a bit of a mess here, but actually it's not so terrible. So yeah, this stuff over here was the docstring of print, and it just gets pulled into the question mark. It's just very convenient. So if I didn't do this, if I just said, I don't know, made it a comment like that, then it says no docstring, because it's expecting after that line where you define the function like a particular format, so it knows where to pull that information from. Okay. Questions? Okay, so there's a few types of docstrings. This one above was just a single line, and that's occasionally sufficient if it's pretty obvious what the function does and you think people will just be able to figure it out. You just throw in a single line docstring. There's many different styles of docstrings. I'm just going to show you two of them. One of them is PEP8. PEP8, we'll talk about that next week, but it's just a particular guideline for style of Python code. And it has a description here, and then arguments, and then you say what the arguments are. The name of it is string. This is the data type, str, which is string, and then the string to turn into a palindrome. So again, you can use the question mark, and you get the docstring just showing up in here. Just a second, Ryan. And then the other one is the SciPy style that is a bit more elaborate. So you might have a very short explanation of what it does, a longer explanation of what it does, a listing of the parameters in this particular format. And what I really like about this is a list of what the function returns, which is also pretty important. You would like to know that if you're using a function. So in this case, it also returns a string. And then an example, which in this case is just incredibly useful. Like, as soon as you see the example, you can kind of just get what the function does in a way that a paragraph of text is maybe as good as, but this is just super nice. Ryan?
Small question. When you use the question mark to bring up the help, I noticed yours came up in like a separate window.
Yeah.
I do it.
Yeah, the question was, why does the help come out in a separate window? I don't even really want it to be coming up in a separate window. It might be a Jupyter Notebook versus Jupyter Lab thing. I usually use Jupyter Lab, but just for, Tom, yeah.
Yeah, if you open your brackets after the function and then press Shift-Tab, it's nicer.
Open the brackets.
Oh, you can close them, but
I see.
It shows you the docstring as a pop-up.
Okay, thank you, Tom.
Type as much as you want, and you can still press that.
Nice.
Yeah.
Okay. Press Shift-Tab here to get docstring. Okay, this is clearly not going to run. Great. So, here's like the template for this SciPy style. If you have a bunch of arguments, which they're calling parameters, nothing really new here. Here's what you probably want to know, which is what are we okay with? So in the program, we are okay with the one-line docstrings for very short, kind of self-explanatory functions, and either of those two styles that I just showed you for longer docstrings. I personally prefer the second one, the SciPy one, especially because it shows the return type, which is usually useful to see, but you can use whichever of those styles, and there's this code quality rubric, which you may have seen in the lab, and one of the things you need to do to get the code quality marks is to properly document your functions. Questions?
So this is the way we...
Oh, wait, what's your name?
Victor, sorry.
Victor, yeah?
And so this is the way we document the functions.
Yes, this is the way we document the function. Yeah, and the reason why we do it this way is, as I said, there's a bunch of other things out there expecting you to document your function in this way, and it can grab that and do nice things with it, like what Tom was just saying, and like some other stuff I'll tell you in a second. But let me just quickly say keyword arguments. So if you have keyword arguments, In this style, you should just say what the default is in the docstring again. So if someone pulls up the docstring, they can see what the default is. And in this style, same thing. You say that it's optional, and you say what the default is. Okay, so yeah, one other thing is there's a bunch of libraries that will generate like a web page for you. We haven't written that much Python, but people write entire packages with many functions and classes and files and all these things we're going to talk about, and it'll just make the documentation for you. So, for example, here's this scikit-learn, which is something we'll use in a later course. Here's this documentation for some scikit-learn class. And it looks pretty nice. Like things are bolded and indented, and it's quite pretty. And no one actually, hired a web developer to spend half an hour making this thing and typing in the HTML or anything like that. Actually, the devs just had these. So here's the code. All this software is open source, so we can look at the actual code. This is just the actual code, the real actual code. And here's this enormous docstring using the SciPy format. And it has all this junk in it, blah, 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 examples, notes, warning, you name it. And that just got automatically turned into this pretty web page using some piece of software. So that's super valuable, because once you've written everything with docstrings, you pretty much just press the button, and then you have this web page explaining to people how to use your code. So that's super, super useful. Right.
So specifically for like when they generate these docs, like you have to use like parameters instead of arguments for this.
I don't actually know how sensitive these softwares are to perfectly adhering to. Yeah, you can test that out, but might as well just adhere to it, I guess, because why not? Yeah. So here's some libraries. You can look into them if you're interested. Moving on. So what makes good documentation? So here's some documentation I wrote to be provocative. Make palindrome. Turns the string into a palindrome by concatenating itself with a reverse version of itself. To do this, it uses the Python syntax of : -1 to flip the string and stores this in a variable called string reverse. It then uses plus to concatenate the two strings and return them to the caller. So this was meant to be kind of silly, but I'm trying to illustrate some general principles about how to write good documentation. The main general principle is that you usually do not want to say how you are achieving what the function does. You just want to say what it does. And that's kind of the whole beauty of like this ecosystem where people are contributing functions and things, is that maybe that scikit-learn, for example, that I just showed you, some machine learning thing, it just tells me what it does, so I'm going to use it, and then maybe they change how it does it next year to use the next greatest algorithm, but it still does the same thing, and I don't really care. I'm just going to keep using it, and maybe I'll benefit from those improvements. But I don't really need to know or want to know all of that stuff. In a sense, the person who wrote the function is promising me that here's what it's going to do, but they're not promising me here's how it's going to do it. There's some exceptions here, like, again, if running time is a big thing, you might care what algorithm it uses, because maybe one's going to be super slow, or I don't know, some cases like that. But generally speaking, the only thing you really want to talk about is what it does, meaning what are the inputs and what are the outputs. Questions or comments?
So this is not the way we should do it.
Correct. Let's. Yeah. Any.
Here you call them arguments, and in the previous function you call them parameters.
Yeah. Parameters and arguments and inputs, they're all kind of synonymous. You can any of those are reasonable terms, yeah. Okie dokie. Yeah, so we just talked about this. Okay, next thing is tests. So in your lab, you have seen a bunch of asserts. Assert statement in Python will cause your program to fail if the condition after it is false. Okay, and so asserts can be used as sanity checks to make sure your program is doing what it's supposed to be doing. In your case, in the lab, it's just checking, does your... The ones in the lab are a little more invasive, I guess, than usual, because the ones in the lab actually check how did you do things. They're like, did you define this variable? That's more of a scaffolding teaching thing. But the real use of these in your future lives is to just test, did the code do what it was supposed to do? And there's also some of that in the lab as well. So the way it works is assert, and then an expression that needs to evaluate to either true or false. So just like an if statement, it's going to try to get a Boolean out of whatever you put there, and then some message. So for example here, 1 is not equal to 2, so it's going to throw the error and give me the message, 1 is not equal to 2. Okay, so some people like to write their code in this particular way, which is first writing just deciding what the inputs and the outputs are, the data type. So the docstring kind of stuff. And then writing the tests. And then, okay, pseudocode meaning like halfway between language and code. People might or might not do that depending on how complicated the thing is. And then write the code and then polish up the documentation. So the whole thing this is really trying to say is what's unusual about this is writing the tests before writing the code. So a lot of people like to do that. And there's a lot of value to that. You don't have to operate this way in your life if you don't want to. But it's worth considering. And I think, at least to me, the real benefit of this is that often I just start writing a function without having it crystal clear in my head what it's actually supposed to do. And then I'm simultaneously writing code and deciding what the code is going to do. And that's just like way harder than doing one thing at a time. So you're kind of isolating the thinking it through from the implementation. And actually writing a test is an awesome way to think through what your function is going to do. Because you're like, well, if I give it this, it should do that. And if I give it this, it should do that. You're kind of nailing down the behavior of the function one assert at a time. And then you say what the inputs and the outputs are, so it's all clear. And then you've kind of gotten it clarified, and you can just go do the implementation. So in a sense, in your lab 1, we kind of did this for you because we already gave you the tests. But the real leap is if you're just given a blank page for you to actually write your own tests before you're writing the function. So highly recommended to try out this approach, especially for more complicated functions that you're going to be writing. And yeah, this is not a programming language specific idea. This is just a general programming idea. Okay, so testing woes, things that can go wrong. The biggest thing that can go wrong, so just to be clear, I'm using the word test like an assert is testing whether something that should be true is actually true. And then you write a bunch of these tests, and hopefully they all pass, and then everything's okay. And if they fail, then something was misaligned, and you have to fix it up. So a very common thing is that all your tests pass, and you're really happy. You go home early and work early for the day, but your code is not actually right. So you need to deal with that by writing lots of tests. And even after you write lots of tests, still always keep some skepticism about your code. So here's an example. Just finds the median, the sample median of a bunch of numbers, and here's how it's going to work. It's going to sort x, and then it is going to take the middle element. So to get the middle element, I'm using this integer division we talked about last time. So say there's 5 things in there. It is going to take length of x is going to be 5. Integer division that by 2 is going to be 2, and so it's going to take the third element, and that's all good. So I wrote some tests. Sample median 1, 2, 3, 4, 5 should be 3 because 3 is the middle element. Great. And sample median 0, 0, 0, 0, 0 should be 0. Test pass. Great. Done. Except these tests that I wrote were not enough to get the job done. So here's another test that maybe I decide the next morning when I get back to the office, well, I should add this one more test, 1, 2, 3, 4. And now suddenly it doesn't pass. So what's actually happening here is that when there's an even number of elements in the list, our definition of the sample median typically is that you kind of take the 2 middle elements and you take the average of them. So in this case, 2 and 3, the average is 2.5, but I never actually implemented that in my code, but I also never tested for it. But now imagine you're doing it the other way around. Imagine you wrote this test first because you're like, well, what are the properties of a median? What is the definition of the sample median? You're like, oh, this and this and this. Then as soon as you write your code, that test is going to fail, and you'll say, oh, yeah, I forgot about that. But when you're kind of doing it all at once and caught up in the implementation, things might slip your mind. So by just focusing yourself on the behavior and not thinking about the implementation, you can really be more effective. Okay, great. So let's just, I don't know. Well, we could fix that. Maybe I won't do it live. But so there's clearly a problem with even numbers, that it doesn't do the averaging thing. But for odd numbers, it's all good. Here's another test for odd numbers. Oh, well, even for odd numbers, it's not working. That's weird. The median of 1, 3, and 2 is supposed to be 2. What's going on here? Well, I'll tell you what's going on here. This sorted thing returns a copy of x that is sorted. So I confused this with, well, now it gets a bit complicated. So I could do x.sort, which will actually change x. But now we get into this side effect business that we talked about earlier, that we don't want to mess with x. So this will be the topic of Tuesday's class, actually. But let's just do this for now, and so we don't get too distracted by that. So this would solve the problem. And so why did that happen? It happened, why did it happen that our tests reassured us when they shouldn't have? That's because this test case, the only test case I had with odd numbers, the list was already sorted. So it worked because I didn't need to sort the thing. But, 1, 2, 3, 4, 5, that's an obvious thing. Like, who can blame me for making that my test case? And yet, it actually caused me to be misled about whether my function was correct. And so we have to just be very careful about these things. It is so easy to run into this kind of trouble. You might think, okay, I need an odd test, I need an even test. Done, right? But even that might not be enough. You have to be quite thorough with these kinds of things. Any questions about this? I forget. Sam. Okay, right.
Would you ever leave the asserts in your code to prove to others that your code works? Like if you have building a package?
Would you ever leave the asserts in your code? So that's going to be the topic of a later course, like automating this whole testing thing. So maybe we could just leave it till then. But also there's sometimes like a way to disable asserts when you're running the code, and because sometimes people are actually worried about the speed of the asserts, just like maybe the tests actually take a long time to compute the thing and you just don't want to bother. So you typically don't want your test to be running when the end user is doing the thing it's meant to do. You typically want it to be running every time you make any change to make sure everything's still okay before you ship it off to the end user. Question somewhere over here, I think. Maybe not. Serge.
Yeah, thanks. So, sad that asserts can be turned off like
for like production build or something like that, does it mean that we should not use them for some sort of like checking the arguments, stuff like that, which
Yeah.
normally it should be run even in production environment, right?
Correct. So we'll talk a bit next week and a lot in a few months about like the proper way of doing all this for writing a package or something like that.
Thank you.
Yeah. Okay. Right. So those are what I call false positives, meaning the test says everything is okay, but actually it's not okay. You could get false negatives, which are even more frustrating. Happened to me many times in my life where the code was actually right and the tests were wrong. Seriously, that does happen to me a lot. But that happened to some of you yesterday with some of the poorly designed assert things in the lab where there was a slight round-off error. If your spin times were a certain way, it failed, but actually everything was okay. That's one of the issues I posted in. So the tests can mislead you in either direction, and nonetheless, they're absolutely critical to have. Okay. Corner cases, this is just to say, often you want to test like the weird cases, like a list with just one element in it, because those are going to be often the cases where things go wrong. So you'll usually want to test some general cases and some weird cases, which we typically call corner cases. Okay, last thing of the day. So typically, when you're programming, a function can take in a whole bunch of inputs or arguments or parameters and just return one thing. But sometimes, not that often, but sometimes you actually want to return more than one thing. So here's a bad example. I would hope you wouldn't do this because, I mean, sum and product, like, why not just have a sum function and a product function? This is bad design, I would say. But sometimes it's good design, especially if there's like a lot of computation and then it produces two things at the end. And if you separated them and someone wanted both, the computation would be done twice because they call function A, it does all the computation, gives you the first half of the result. They want part B, it does all that computation again, returns the second half of the result. Just give them back the two things right away. That's like a typical case. Here it just makes no sense, but I'm just showing it to you. So what you can do, the kind of hack in Python, is that, well, you can only return one thing, but tuples can have a bunch of things in them, so just return a tuple, and you're kind of working around that restriction in a sense. Occasionally useful, yeah, so maybe I should not good from a design perspective. And also, you can actually omit the parentheses. So these parentheses are kind of implied. It's like an implied tuple. I'm just telling you this because you're probably going to see it and wonder what's going on. So this is exactly the same, even though there's no parentheses. This is still turning itself into a tuple. Another thing you can do on the caller side, so this is the defining the function side, but on the calling the function side, you can again use the comma thing to unpack the tuple right there in the same line that you call the function. So s comma p equals sum and product of whatever, 5 and 6. That's going to return a tuple, 11 comma 30, and it's just going to unpack for you. It's going to stick the 11 in s and the 30 in p because it sees that there were two things coming out and there's two things right here. And so that kind of works. And then sometimes if you don't want one of the two things, you could just use this underscore to say, actually, I just don't want the other thing. Okay. And then just one more thing with tuples. That's kind of nice. So you can do this in Python, and you can do this in Python. And you can even do this in Python. So in most languages, like when you learn programming, it's like, how do you swap two things? Well, you need a temp variable. Temp equals A, B equals temp, A equals B, or whatever it is. But in Python, you can actually do A comma B equals B comma A. And as I said, it just kind of packs the thing on the right, passes it over the equal sign in a sense, and then unpacks it into the other order. And so this actually swaps A and B. So I'm out of time. I saw there may have been a couple questions. Just feel free to post them in Slack or come to office hours. And we'll see some of you in lab later in the week if I haven't seen you already.